So as we work here on page 21, 22, 23, we're gonna first, for all these problems, we're gonna identify the system. And the way I want us to identify the system is we're going to put these dots going around this object. So I have here these dots going around, and this is showing that everything included in the system is encased in this dot going around. So we have here the chandelier. We also have the cable or chain rather. And so that's what we have here for the system. The second thing we're going to do is we're going to draw the free body diagram. So we're going to draw that free body diagram. So all the forces acting on this object on this free body diagram. So I'm counting the chandelier as this box. And then all the forces acting on it. So we have this force due to gravity, which we can label as mg. You can also label it as F sub g, however you label it, as long as you're making it clear that this is the force due to gravity. I have it m times g because that's the equation we have. We're also going to have a force up. This force up is that force due to tension. So an F sub t for tension. And we know that it's tension because it's this chain right here that's holding it up. So that's what we're going to have there. For 1, identify the system. 2, draw the free body diagram. 3, we're going to put in those equality marks. So for these equality marks, I mean getting a mark there and a mark there. We know that this up force is equal to this down force because this is suspended, it's motionless, it is not changing its motion. We know that this force up has to equal to this force down. This is not accelerating, it's not changing its motion. So 1, identify the system. 2, draw the free body diagram. And 3, those equality marks. The last part that we're going to do here is number 4. This is where we're going to get to the sum of the forces. So this sigma F. So the sum of the forces here, this is the sum of the forces. And what we're doing is we're going to add up all the forces. And now we're going to do this in the X and some of the forces in the Y. So we got to do this for both the X direction and the Y direction. So we're going to get the sum of the forces here in the X. That's everything going left and right. There's nothing. So this is equal to 0 newtons. We're also going to have then the sum of the forces in the Y. So the Y direction, this is going up and down. So the sum of the forces here in the Y, we have this tension force up minus this mg down, minus because it's going down. So this tension is up, so it's a positive. We're going to add in the mg, but the mg is going down, so it's negative, so minus mg. This all equals to ma, because the sum of the forces equals to ma. Tension up minus mg down equals to ma. But if we said that this equals to this, so say this tension was 10, mg is also 10, that means 10 minus 10, which is 0. So we know ma equals to 0 newtons as well.